Hi everybody, hope all of you are well. Today our topic is ethers. So this is the last portion of your chapters, that alcohol, phenols and ethers. First we have to know what is the structure of ether. If we write both sides of oxygen, there is two alkyl group, that is called ether. Or if we replace one hydrogen of alcohol by one alkyl group, that is also called ether. And in this case, this is called diaryl ether. Diaryl ether. In on the both side of oxygen, if there is phenyl ring or aromatic benzene ring, okay, then it is called diaryl ether. Diaryl ethers. Next, we will discuss the classification of this ether. Ethers may be three types. One is aliphatic ether. Aliphatic, that is the classification. Aliphatic ether. Aliphatic ether may be two types. One is simple ether. Another is mixed ether. In simple ether, it will be symmetrical. Both sides there will be same alkyl group. So both sides there is methyl, that is dimethyl ether or diethyl ether. These are simple ether. But in case of mixed ether, both sides there of oxygen there will be the different group. In one side methyl attached to the oxygen and another side ethyl group. So this is methyl-ethyl ether. Okay. So this is one mixed ether. Hope you can understand. Next we will discuss aromatic ether. Second, aromatic ethers. In aromatic ethers, both sides there may be aromatic ring, or one side there will be alkyl, another side aromatic. And based on this can be divided into two parts. One is alkyl aryl ether. Alkyl aryl ether. Another will be diaryl ether. In case of alkyl aryl ether, one side there will be alkyl group like methyl, in another side there will be aromatic ring or aryl group. And this is nothing but anisole. And diaryl ether, in both sides there will be aromatic ring. It is dibenzyl ether. Hope you can understand. Next we will discuss one more type of ether, that is called cyclic ether. Cyclic ether, we can think about this one 1,2-diphosphene, or it is called oxygen. If we draw this one, this is called 1,3-epoxypropane and this is called oxytane, and this one is called tetrahydro furan. So these are the examples of cyclic ether. Next we will discuss the nomenclature of the ethers. Ethers may be named as, actually in case of IPSC, there may be two type of name. One is called common name or trivial name, another is IPSC name. In case of common name like dimethyl ether, diethyl ether, ethyl methyl ether, these are common names. CH3, OCH3, common name is dimethyl ether. But its IPSC name its IUPAC name is alkoxyalkane, so it is methoxymethyl. This is IUPAC name. Next, CH3O CH2CH3. This is a mixed ether. The name of this mixed ether is ethyl methyl ether. Common name. Ethyl methyl ether. This is the common name. And what will be the IUPAC name? IUPAC name will be methoxyethane. Methoxyethane. As this one is the longest carbon chain, so this is the substituent. So here we have to write alkoxyalkane. So this is methoxyethane. Next we will take the examples of aromatic ethers. Like if we think about this one, we have already told you that this is diphenyl ether. But what will be the IUPAC name of this diphenyl ether? It will be phenoxybenzene. Phenoxybenzene. And if we write this one OCH3, its common name is anisole, and its IUPAC name will be methoxybenzene. Methoxybenzene is the IUPAC name. So in this way we can write the common name as well as IUPAC name that you will practice from your textbook. Next we will discuss the preparation of ether. We have already discussed that the acidic dehydration of alcohol. So one preparation method of ether is acidic dehydration of alcohols. If we take ethyl alcohol, and here we have to give concentrated sulfuric acid, and temperature should be around 140 degrees centigrade, then we get that C2H5O C2H5 plus H2, and this is diethyl ether. So in this way we have to take only primary alcohol can respond this type of test, primary alcohol. Okay. Now here the temperature is very much important. Here we have taken concentrated sulfuric acid, and temperature is very much important. Why? Because if we increase the temperature, if we heat around 170 degrees centigrade in presence of concentrated sulfuric acid, then there will be different product. We will get the elimination product ethylene plus H2. So temperature is very important. Again I am telling you that you have to mention 140. If you write 170 or if you write below of it, then there will be different product. So that is very important. And another important method for preparation of ether is Williamson synthesis method. Williamson synthesis method. In this method, we have to take one alkyl halide like C2H5Br and one alkoxide like sodium ethoxide NaOC2H5, and if we apply heat, then there will be formation of C2H5 OC2H5 and C2H5. This is diethyl ether plus NaBr. Now this is a very good method by which we can prepare both symmetrical ether as well as unsymmetrical ether. But the previous, that the acidic dehydration method, we only can prepare the symmetrical ether. But here we can prepare both symmetrical as well as unsymmetrical. We can prepare aromatic ether also by this Williamson synthesis method. Here we have to first add NaOH to phenol, then it will form phenoxide ion. Then if we add methyl bromide, that will produce anisole. There is one aromatic ether. And if we want to prepare phenitol, then with the same starting material we have to take O minus Na plus, and if we give C2H5Br, that will produce phenitol. So this is one kind of bimolecular nucleophilic substitution reaction. Okay. Now there are some limitations of this Williamson synthesis method. If we want to prepare ether like this one, diphenyl ether, we cannot prepare diphenyl ether by this method. So we have to go through the benzene mechanism or benzene intermediate. That we will not discuss, but one very important thing today I will discuss, that if we want to prepare this type of ether, then what would be the starting material? There are two options. We can take O minus Na plus bromide. Otherwise we can take bromide, tertiary butyl bromide plus O minus Na plus, sodium ethoxide. What will be the right choice? Here in this case we will get this product. We apply it, we will get this product. That means substitution product. So this is the right method. But if we take this one, you know that this is also not only as a nucleophile but also a good base. So there will be elimination reaction and we will get some alkene, not the ethers. So there will be different type of product, and there we will get C2H5OH alcohol plus NaBr. So hope you can understand that here in case of tertiary butyl bromide, if we take tertiary butyl bromide, then their asymptotype reaction will be very difficult because these are the bulky group, they are sterically hindered, so the nucleophile cannot attack here. So definitely there will be elimination reaction. So the major product will be the elimination product. Okay, so in this way we can prepare the aromatic ether as well as the aliphatic ethers. And Williamson synthesis method is the best method. And if we take some dehydrating agent like aluminium oxide by catalytic at higher temperature around 350 degrees centigrade, then also from ethyl alcohol we can produce ether. Next we will discuss the physical properties. Physical properties. Generally lower member ethers are gases, and some lower higher members or lower members they may be liquid, like methoxymethane. Okay, this is a gas, but if we think about the ethoxyethane, the diethyl ether is liquid. Okay, and all ethers have some present order. If we think about their solubility, the lower members are a little bit of soluble in water because it can form hydrogen bond like this. Basically, we can tell about that the tetrahydrofuran. Tetrahydrofuran is fully soluble in water. THF, tetrahydrofuran, is fully soluble in water. But diethyl ether is not soluble in water. So we can extract in different types of organic compounds during the after ending the reaction workup. Okay, and there will be two layers. One will be aqueous layer and another will be the organic layer. That layer we can use that ether to extract the organic compound. And solubility of the ethers in water decreases if we increase the chain length of the alkyl group, as the tendency of the hydrogen bonding, formation of hydrogen bonding decreases. Ethers are also soluble in organic solvents like benzene, chloroform and acetone, ethanol, etc. Next we will discuss the density. Maximum ethers are less denser than water. Less denser than water. That is why if we take diethyl ether and water, diethyl layer will occupy the upper position, okay, or the upper layer of the mixture. So they are less denser and ethers are highly volatile and they can easily catch fires. They are, if you think about the diethyl ether, its boiling point will be near about 33 degrees centigrade. Okay, so hope you can understand. It can easily form, it can easily go to the vapor state and it can easily catch fire. Okay, now the boiling point, the CO bonds in ether are polar and the ethers have a net dipole moment. So if we draw the structure, you can easily understand, like CH3, OCH3. So definitely lone pair moment will be towards this, and this methyl moment, okay, that the bond moment of this oxygen and carbon, that will be that side. So definitely it will be a polar compound. And the weak polarity, not so much polar, but there is some polarity. So this weak polarity of ethers do not appreciably affect their boiling points, okay, which are comparable to those of alkanes. If we think about the pentane, boiling point of pentane is around 309 Kelvin. If we think, or if we talk about diethyl ether, its boiling point will be 307 Kelvin. But if we take alcohol, like if we take butanol, its boiling point will be 390 Kelvin. So here boiling point is very high. Why? Because the hydrogen bonding in this alcohol is more effective. That is why its boiling point is very high. Hope you can understand. Next we will discuss the chemical properties of ether. Chemical properties. Actually, in case of ether, that oxygen and carbon bond is very strong. We can do the substitution reaction in the alkyl part. It is a halogenation reaction. Halogenation. If we take diethyl ether and add chlorine in the dark, then there will be replacement of hydrogen by chlorine. And the next step, if we add another mole of chlorine in the dark, again there will be replacement of another hydrogen. So you will get this type of compound. Okay. Now if we add excess chlorine, then what will happen? Here if we add 10 Cl2, okay, here we are not using this reaction in the dark, okay, we are using excess chlorine, and in presence of light we are doing this reaction. then all hydrogen will be replaced by chlorine. So it will form CCl3, CCl2, O, CCl2, CCl3. Okay, plus 10 HCl. Next we will discuss the action of ether with concentrated sulfuric acid. Action of ether with concentrated H2SO4. So if we take concentrated sulfuric acid, then there will be protonation of the oxygen, OC2H5, concentrated H2SO4, and we are adding in cold condition. Then there will be C2H5O, the oxygen will be protonated from the sulfuric acid, and there will be formation of one salt, HSO4 minus, and this salt is called oxonium salt. Oxonium salt. Next we will discuss the action of oxygen or air formation in presence of peroxide or formation of peroxide. Actually, ether can react the oxygen present in air, and there it is need long contact. Okay, in presence of long contact of oxygen, okay, in presence of light also, it can form peroxide of diethyl ether. So C2H5OH, OC2H5OH, so it will react with oxygen in presence of light. There will be formation of peroxide, CH3, CH, OH, O, C2H5. That is why generally ether like solvents or ether like compound are stored in black bottles where light cannot enter. Okay. Next, how to understand that there is peroxide? There are different types of tests. If we add some ferrous salt, it will be converted into ferric. Then if we add ammonium thiocyanate, then it will show red coloration. From here we can easily understand that there is formation of that peroxide in ether. And this is very much dangerous, because if we want to distill, okay, ether containing peroxide, there may be explosion. Okay, so before distilling the old ether or storing for the long time, okay, we have to check whether it is peroxide free or not. Next we will discuss the action of halogen acid. C2H5O, C2H5, if we add especially the HI, hydroiodic acid, and we have to use the temperature around 370 Kelvin, then there will be formation of alcohol plus ethyl alcohol plus C2H5I, iodoethane. If we add excess HI, then there will be formation of C2H5O, C2H5 plus HI excess. Then there will be formation of C2H5I only. Okay, with the formation of also water will be there. Now if we take anisole, so here oxygen is attached with alkyl group. Here if we add HI, in the heat, in presence of heat will be around, temperature will be around 370 Kelvin. There will be formation of phenol plus methyl iodide. Whatever we are discussing, all the cleavage of CO bond. Actually, CO bond is very much stable. We are using acid here, so oxygen will be first protonated, then there will be substitution reaction. Next, we will discuss the aryl ethers. Aryl ethers also prepared by Williamson-Synthesis method. We have already discussed. In aryl ethers, the presence of alkoxy group activates the ring and direct the orthopara substitution with respect to OR group. Now we will discuss some substitution reaction of these aryl ethers. If we take OCH3, this one is anisole. Okay. If we add bromine acetic acid, then there will be addition of bromine in OCH3 at the ortho position as well as the para position. Ortho para substitution product. But which one will be the major? Definitely para will be the major product. So in this way we can do any type of substitution reaction. If we take this anisole and if we add the nitrating agent, that means mixed nitric acid, mixed acid, concentrated HNO3 and concentrated H2SO4 1:1, definitely there will be nitration at the ortho and para position, and para will be the major product. Definitely para will be the major product. We can do Federal reaction also. If we take OCH3 and give anhydrous AlCl3, and if we take methyl iodide or methyl chloride, then there will be formation of orthomethyl anisole plus paramethyl anisole, and definitely the para will be the major product. And in the same way we can do acylation. If we take acetyl chloride in presence of anhydrous AlCl3, there will be ortho acylation of this anisole, and para will be the major product. Last we will discuss the use. Ethers are solvents. Ethers can be used as solvents both in laboratory as well as industry. Diethyl ether widely used in the extraction of many organic compounds from natural sources, and diethyl ether has been used as anesthetic. Okay. Now we are using some haloderivatives of this diethyl ether as an anesthetics. And diphenyl ether also we can use as heat transfer medium, as it is its boiling point is around 258 degrees centigrade. That is much higher. So in this way we have completed this chapter. Hope you can understand. Okay, if you have any question, you can send these questions to the YouTube comment box. Otherwise you can send my email. Okay, so today up to this. Okay, thank you.